Next, the other types of logical connective, which is called implication. Implication can be defined as follows. When two propositions are joined with connective implies, the proposition formed is a logical implications, and the connective implies is denoted by like this. By simple this. Dear, when we say implications has another name which is called conditional. So that the logical implications or conditional statement of two propositions, say P and Q, is written as like this. And we can read this as P plus Q or if P then Q. Not only this, there are different ways or expressions for these implications, and we will see it now. These implications or that means this implication is the rule for implication said that P implies Q or if P then Q is false. If and only if P is true and Q is false, otherwise true. Or in other ways, when the first proposition has truth value true and the second one is which is false, and if they are joined with the connective implies, then it has truth value which is false. It means if that means true implies false is which is false, so that P implies Q is false if P is true and Q is false, otherwise true. Using that of truth tables for two propositions say P and Q, so that way for only two propositions P and Q, P has possible truth value true, true, false, false, and Q has possible truth value true, false. So that's using the rule for implications. P implies Q is false. If P is true, Q is false. So that true implies true is true. True implies false is false. False implies true, true. False implies false is true. Example. Consider the following propositions. Let's P. 3 is an odd number, which is true. Q. The proposition Q says that 27 is a prime number, which has truth value false. R. Addis Ababa is the capital city of Ethiopia. This has truth value which is true. So that P implies Q can be written as if 3 is an odd number, then 27 is a prime. So that this statement has truth value which is false because 3 is odd number, that means which is P is which is true, and 27 is a prime number which is false, so that true implies false is which is false, so P implies Q is false. P implies R. P implies R can be written as if 3 is an odd number, then Addis Ababa is the capital city of Ethiopia. And it has truth value which is true because this is the same as true implies true. True implies true is using the rule is which is true. Dear, there are various ways of expressing the propositions P implies Q. These propositions P implies Q or the implications of statement P implies Q as or can be expressed from all of these one. We use one of those so that we can read as this P implies Q can be read as if P then Q, Q if P, P implies Q, P only if Q, P is sufficient for Q, Q is necessary for P. All of those expressions are equivalent to P implies Q or this statement P implies Q. Bi-implications. When two propositions are joined with connective bi-implication, the proposition formed is called logical bi-implications. A bi-implication is denoted by this. Dear, bi-implications has another name which is called bi-conditional. And the rule for bi-implications or bi-conditional is given as P bi-implies Q. Or first, how we can read this? We can read as this P by implies Q or P P if and only if Q. Not only this, there are another expression for this we will see. Now, this P by plus Q is the same as P if and only if Q, or another ways we can read as is if P then Q and if Q then P, and there are a lot of expressions. Now let us see the rule. P by implies Q is false if and only if P and the Q have different truth value, otherwise true. Or in other words, we can express this as P by implies Q is true if and only if both P and the Q have the same truth value. Otherwise, it is false. Therefore, P by implies Q is false if both of the two statements have a different truth value, and P by implies Q is true if they have the same truth value. Using truth table for two propositions like P and Q, then P has possible truth value true, false, false. Q has possible truth value true, false, false. So P by implies Q, or P if and only if Q has truth value, that means true by implies true is true, true by implies false is false, false by implies true is false, because those statements have a different truth value. But false by implies false is true, because this if F or and the true they have the same truth value, or the same truth value true, then by using ways they are connected by implies, then they become true. The same as false by implies false is also which is true. For instance, consider the following propositions. For given propositions P, 3 is an odd number. This is true. Q, the proposition Q is given as 2 is a prime number. This is also true, because 2 is a prime number. We know that because 2 has only two factors, 1 and itself 2. So that 2 is prime number, which is true. So how we can write P by implies Q? P by implies Q, or P if and only if Q can be written as. So there, cancel this if is unnecessary, so that we can write this as 3 is an odd number if and only if 2 is prime number. Or in other ways, we can write as this as 3 is an odd number by implies 2 is a prime number, and the truth value for this is which is true, because both statements P and Q have the same truth value, which is true. So P by implies Q is true. There are various ways of expressing the propositions which is P by implies Q. This has the same as which is P if and only Q. P implies Q and Q implies P. Or another way is if P then Q and if Q then P. Another thing is which is P necessary and sufficient for Q. Q is necessary and sufficient for P, and or P is equivalent to Q. The last but not the least of another types of logical connective is called negation. This is different from another logical connective because it may be applied for only one proposition. So it can be defined as, for given any proposition P, we can form a proposition which is like this negation of P, which is called the negation of P. The rule for negation P says that, or the truth value for negation P is false if P is true, and it is true if P is false. Using a truth table, the truth table is given as I told you, that just the negation may be applied for only one proposition, say P. So here we have one proposition P, therefore P has possible truth value only true, false, because we have only one proposition. So that's the truth value for negation P. That means if P is true, then negation P is false. If P is false, negation P is true. For instance, let P given as Addis Ababa is the capital city of Ethiopia. Negation P is given as Addis Ababa is not capital city of Ethiopia, therefore this is false. Here from P Addis Ababa is the capital city of Ethiopia. This has truth value which is true, and its negation is negation B means Addis Ababa is not the capital city of Ethiopia, which is false because negation of true is which is false. Thanks for watching my video. We will continue the exercise which is done under those logical connective, and we will see in other parts. So dear, don't forget to subscribe, like, share, comment.